The last lecture for Chapter 5 will cover lipoproteins. You can't talk about lipoproteins without first reviewing cholesterol. So cholesterol is found in the highest amounts in the nervous system and the lowest amounts in the heart, which makes sense. We don't want cholesterol plaque building up in our heart vessels. It's a waxy fat-like substance, and it's technically classified as a steroid. It has various functions in the body, which I think sometimes are underappreciated. It maintains cell membrane integrity, bile salt production, produces the sex hormones, or plays a key role in producing the sex hormones. It's necessary for vitamin D conversion with sunlight exposure. We'll talk about vitamin D in another lecture. Growth and maintenance of cells, and that covering of your nerve cells, the myelin sheath, is comprised of cholesterol. We do manufacture cholesterol in the body. About 2/3 of it is synthesized endogenously or within the body. And we get 1/3 of it, about 1/3, from the diet. So foods that are of animal origin, of course, contain cholesterol. And 90% of cholesterol is free cholesterol found in the cell membranes. But you can also find cholesterol in various other places: lymph, bile, cerebral spinal fluid, milk, urine, adrenals. The list goes on and on. So after you eat a a cholesterol-rich meal, there's only a very small increase in your cholesterol. In fact, it's only 0.05%. And that small amount of cholesterol that you ingest in your diet results in a dramatic reduction of synthesis in the liver. If you notice, it's 95% decrease. And the synthesis of cholesterol, however, in the intestine will continue despite dietary intake. If you're consuming more than 500 milligrams per day of cholesterol, the absorption is going to decrease. And when you don't consume adequate amounts of cholesterol, the absorption becomes much more efficient. Any cholesterol that is not absorbed will be excreted. It could also be incorporated into the enterocyte membranes, so the cells of the small intestine. And the majority of it, though, is esterified and prepared for transport out of that cell into a chylomicron. So I skipped one, sorry about that. So how do we know, or what will determine the amount of cholesterol that we'll have in our bodies? Well, I told you 1/3 of it comes from dietary intake. What percent of it is absorbed? Most of it's absorbed in the duodenum. Genetically, what are we predisposed to produce in terms of cholesterol synthesis? There's some various lipid disorders, and some of us make more endogenous cholesterol than others. It's moved, it's transported from location to location within the body, and with degradation and excretion, it ends up in the feces. There are 5 major classes of lipoproteins. There's the chylomicron, VLDL, LDL, IDL, and HDL. And really, you could have a whole, and there is, I've taken a whole semester on lipids. So this is just the tippy top of the iceberg, but it will give you a broad overview. And perhaps if you have the opportunity to take a class in lipids, I would highly recommend it. So each of the lipoproteins has, as I was saying, each of the lipoproteins is composed basically of the same ingredients, if you will. There's triglyceride, cholesterol, phospholipids, and that the protein, the phospholipid, allows it to be soluble because we know that lipids are hydrophobic. The head of that phospholipid is hydrophilic, which allows it to be in that liquid medium in the intestinal tract or in the blood. Chylomicrons, let's start with them. They're first on the list. They are the largest lipoprotein, primarily composed of triglycerides, so 90% triglyceride, and this is a reflection of dietary fat. So remember, when you have your triglyceride levels drawn as part of your lipid profile, the doctors want to see, I believe it's under 150, I'm going from memory. And there are some dyslipidemias where triglycerides are in 500 and 1,000 range, and usually those folks end up with pancreatitis and some other issues. If you ingest excessive carbohydrate or a heavy drinker, often your triglycerides will go up. So again, primary carrier of exogenous lipid, meaning lipid that we take into the body. Triglycerides in the chylomicrons, when they're broken down, are hydrolyzed by lipoprotein lipase, and that's found on the cell surface of the intestinal cells, the endothelial cells, and muscle and adipose tissue. the endothelial cells surface of muscle and adipose tissue. ApoC2 is a apolipoprotein which stimulates the lipoprotein lipase to hydrolyze that triglyceride. When 90% of the triglyceride is hydrolyzed, it's released into the bloodstream, and the liver picks it up and further metabolizes it. And what you're left with is something called a chylomicron remnant, and that simply contains less triglyceride, phospholipid, and protein than the original chylomicron. So it's a remnant. And there is some question of whether or not this is atherogenic particle. In other words, it leads to atherosclerosis, heart disease. And this picture is in your book. I think part of it's cut off, so I apologize for that. But it shows you a picture of how the chylomicron, in reference even size related to the other lipoproteins. And again, it's the largest chylomicron. And the picture has peeled away the surface so that you can see into it. You can see the phospholipid head and the cholesterol esters that are within it, and the cholesterol and the triacylglycerol, which I simply call triglyceride. And you can see that HDL is the smallest particle. So review that. It's somewhat interesting, I think, when you compare them to each other. VLDL is synthesized both in the liver and the intestine. And VLDL can be synthesized from chylomicron metabolism. It does primarily carry endogenous triglyceride and cholesterol, so cholesterol that's made within the body. And it's comprised of 60% triglyceride. It's large and buoyant, and they don't think there are any cardiac implications or heart disease implications related to this particular lipoprotein. It has some apolipoproteins, B primarily from the liver, and some C1 and C2. And when apolipoprotein C2 is present, hydrolysis of VLDL will occur by lipoprotein lipase. And then the size progressively decreases, and it will release the surface phospholipid, the cholesterol, and then the ApoC2 will actually be passed along to the HDL lipoprotein. We talked about how lipids were used as fuel when we covered gluconeogenesis, but just as a reminder, there's two different pathways that triglycerides can follow when they're metabolized. So that glycerol backbone ultimately ends up as an acetyl-CoA, which enters the TCA cycle, and then the fatty acids have to go through beta oxidation, and there is an energy yield in that fatty acid oxidation process. Ketone bodies are something that I wanted to touch upon. If you have an overflow of acetyl-CoA in the pathway, you become ketogenic. And what happens is the liver is converting these excess free fatty acids to ketone bodies. And we see this with folks who are on low carbohydrate or low energy diets. Sometimes they actually have a fruity breath from the ketones, and they can be quite cranky in my experience. Ketosis is the term used to describe a mild increase in ketone bodies. Now, in some of these lower carbohydrate diets, they're advocating or promoting this. They want you to be in mild ketosis, and they even have you test for it. It's never a good idea, and it's not something that we would recommend. Ketoacidosis is when you have dangerously high levels of ketone bodies, and that'll put you in the hospital guaranteed. That concludes the lecture on lipoproteins. Please let me know if you have any questions.